I need to find the best way to learn math and science.
It's brilliant.
What? I need to find the best way to learn math and science.
It's brilliant.
What? I need to find the best way to learn math and science.
It's brilliant.
What? I
It's brilliant.
What? I
It's brilliant.
What? I
Okay, hello. Can you just write in the comments whether you can hear me and see me, please? Okay, hello. Can you just write in the comments? Okay, thank you. And the comments are also visible. Very good. Okay, so then we will start in 3 minutes. Thank you. Okay, so hello everyone, this is József Nagy here and welcome to my first live chat, live stream where I am going to do a Q&A session. So if you have some, if you cannot hear me, then just please let me know in the comment section below, because then I can see it here on my other screen, and then I'm going to just show you the screen in front of me. So I will just make myself a bit smaller, like this, and these look good. Okay, so this should be okay here. Very good. So then you can see here my screen, hopefully. So I posted a community post a week ago where I asked you guys to post some questions, and I got several of them. So I will just go through them from the bottom, so the first one, and then go up and then see how far we come today. I mean, if we don't finish, then I can do another live stream next week, for example, or in 2 weeks. And if this is popular, then we can do it every 2 weeks or every month. We'll see. Okay, so let's just start with the first question here. I hope you can, maybe I just increase here the size of the letter so you can read the comments better. Okay, so there was this post. So I have not seen any 3D incompressible pressure-driven flows in OpenFOAM. I want to solve it using DNS and decide to use icophone in hopes to calculate permeability. So been stuck for this. I hope you can clarify this. Okay, so without the error, it's difficult. So what I can say in this case, that if it is incompressible, usually for incompressible flows, you specify the velocity on the inlet and the pressure on the outlet. If you specify the pressure on both inlet and outlet, then it may crash. What usually works is for compressible solvers. So if you run a compressible transient solver and you specify the pressure and the inlet and outlet, it will work. And then yes, you use compressible models, but you can just use the incompressible version of the compressible solver. So this is something that I can say to this question. So try possibly a compressible solver and then specify the pressures at inlet and outlet. There you should be good. Okay, then the next question here. Can I include distance between a fixed point to a node of the mesh in the OpenFOAM solver? Yeah, and here I asked you a question, so I was not sure what you mean, and creating a new solver. Okay, so if I just open up Google, because this should be rather simple. So there is this CFD online post which tells you everything. So you can calculate 2 things regarding the points. So with mesh.c, with this function, you can get the coordinate of all the cell centers. And if you do a for loop over it, then you can get all the cell centers. I'm not sure whether you're looking for this. Alternatively, you can go for mesh.cells, and then for each individual cells, you can get the points. So these are all the nodes of each individual cells. But alternatively, you can also go for what I just typed in here, mesh.points, and with this function you can access the list of all the nodes, but then you don't have the information about to which cell the individual nodes belong. So if you just need the nodes, then mesh.points is one possibility. If you need the cell centers, then mesh.c. If you need the points, so the nodes in each individual cells, then this is the function that you are looking for. Okay, so I hope this answers your question how to access the points, and then the distance is then you define a coordinate and then you specify the certain then you calculate the direction of the two coordinates. I see now a comment. Where can I ask questions? Okay, so currently I'm answering a community post where people could pre-post the questions. So if we are fast, then I am happy to answer questions from the comments. But for now, I would like to go through the questions that were already posted. Okay, then let's see. It would be nice for you to explain how do you approach the problems at hand. For example, I've been thinking of doing a simple propeller. How does the wake before? My first thought would be to simulate everything altogether, but the computational power skyrockets. Facing these types of problems every day, how do you face them? Is there a methodology? Okay, yeah, so I do have a couple of videos on that on my Patreon. So this is a perfect plug for me for Patreon. So if you want to support me, then you can go over to Patreon and support me. There I have tons of additional material, plus now another project that we do on Patreon, so check it out. But if you don't want to support me, then I just give you here a quick question. So first, I would never go in for the kill. So I would never start with the big project, with the big geometry, the big problem. I would always start with a reduced geometry, a simplified problem. Maybe even if it's compressible, try with an incompressible solver first because it's faster. I would always reduce the problem down to a level where the simulation runs in 5 to 10 minutes or possibly in half an hour or an hour, because then you will see the problems and then you can go back also to the mesh if you use a turbulent flow, and then redo the layers if your Y plus is important. So I would never go in for the big case, but first do step by step smaller geometries, reduce the problem, and then add complexity and add physics step by step. So first have a simple result that works, and then step by step add the physics and the complexity in the problem. Okay, so this would be my question to Peter here. So Franco, I am entering the CFD world and there is something that I find a little bit strange in research. Okay, so you have not crossed any liquid solid catalytic reactions, so surface of the solid, but a lot in catalytic in gas phase. Are you missing something? And then the equations should be similar. Well, I am not an expert in catalytic reactions in CFD, so I can just tell you my opinion on that. So possibly it depends on the people who work with OpenFOAM, that only people who are working on catalytic reactions in the gas phase work with OpenFOAM and not anyone else. So as far as I can tell, the difference is that the catalytic reactions in the gas then are solved in the cells, whereas if you have a surface, then they are solved on some kind of boundaries and not in the cells. So that could be a difference, but I mean, it's just to program it, but it's you need the people who program it. So I am not an expert in this, but most probably it's just the fact that nobody had this problem in OpenFOAM and nobody tackled it. So maybe you can try and do it. So because there is a question, I believe, regarding programming, then I will come back to how you can start with programming. So the same Franco, looking for guidance on how to troubleshoot the meshing from the results of CheckMesh, all geometry. Okay, we can do that. Quick tutorial here. Having guidance how to do Snappy and also how CheckMesh. Okay, so how to troubleshoot with CheckMesh. Then let's open up here terminal, and then possibly the best way is if I just open up, it's difficult to type in this way. Okay, Patreon problem, So this is one of the tutorials that in the project that I mentioned. So if I go to the 3D elbow case and then let's just make of the mesh a copy. Okay, so what do we see here? So this is a mesh of my 3D elbow case, and then let's just execute check mesh here. First, I just want to show you the mesh here. This is the mesh 3D case here that I created with SnappyHex mesh. So this is what we will now execute here, and check mesh minus all geometry minus all topology. So if I execute, then I get this error message because I didn't load any OpenFOAM version here. So now, okay, so what do we get here? So I guess you are not so interested in these parts, how many cells you have. I most probably are more interested in the quality of the result or of the cells here. So first is what I look for is how many hexahedra I have and what's the percentage compared to the other mesh or cell types. So I don't worry about polyhedra. Polyhedra are rather good in OpenFOAM, hexahedra are the best. What I do worry about are tetrahedra. If I have some, these could screw up the simulations, especially for Interfoam. Here I don't have any tetrahedra. And then further down, there is the most important entry that I look out for is this here. So the mean volume of the cells, because if you have a negative volume or a volume 0 for any of the cells, then all your solvers will crash. So if SnappyHex mesh failed at some points and you have a negative volume, then so if SnappyHex mesh fails somewhere and you have a negative volume, then you can forget the simulation, then you have to go back. But the other entries regarding skewness and concave cells, these are usually very strict. In CheckMesh, I wish there was a CheckMesh version where the default settings for these weren't so strict. So usually you get an error or a warning if your skewness is at 5 or 10. In my opinion, if you have a skewness of 10, usually the simulation is decent. So this is what I first look for. In addition, what I like to execute is also CheckMesh. What is it called? So write all fields, sorry. This is what I like to execute in addition. Because, no, that's not what I wanted. Where is it? Write all fields. Because this then in 0 exports a couple of wall fields that you can visualize in ParaView. And especially things like cell volume that I mentioned. If you have very small cells or negative cells, then you can just identify where the small cells are or the negative volume cells are, and the cell shapes. So this is related to the shapes, whether you have hexahedra or polyhedra and so on. So if I just quickly open up cell shapes, there you have just numbers, so for number 3, number 5, and so on. And I'm not sure which number correlates to which type of the cell, but you can just isolate them in ParaView with threshold and then see what kind of cells you are. And then there you can also isolate your tetrahedra with these. So this is what I usually do if I use CheckMesh. I hope this answers the question. Okay, so no more questions there. Okay, so then Mauro Baldini. Hi there, first thanks for creating OpenFOAM resources since several years. Yeah, you guys are welcome. I'm always glad to help. My question is, why do you use Windows? Okay, so this is a more general question. I'm a bit of a Linux geek, so am I. So I may be a bit biased by installing OF on Windows. I don't see the benefit, thanks a lot. Okay, so there is a answer from Peter. So I personally, why do I use it? So it's a long So this is the current setup. It was a long evolution for me. Like everyone, I guess, in my age group, we started with Windows 95 and then for a long time we had Windows XP, and I was really fed up with Windows XP because it was slow. There was a huge problem with viruses, and it took a lot of time to boot it up, and I didn't really like it. And then I started to work with Ubuntu, and then I saw that on the same machine booting with Ubuntu was just, they took a minute in comparison to 20 minutes with Windows XP, and then I changed to Ubuntu, and I worked with Ubuntu for a long time. But what I could not get rid of, it was the problem of compatibility with Windows programs, CAD tools, but also the icons that you can see here, Word, Excel, and PowerPoint. Yes, you can use them in Wine, but there was always a problem, and also LibreOffice is not always compatible. And so what I could not avoid was problems with project partners and clients, where they called me on a Friday afternoon that they need my slides for a meeting at 5, a last minute meeting in-house, and I should send them the slides. And then I created all my slides with LaTeX Beamer, and I sent them the PDF, and then they would call me that they need the PowerPoint slides. Please send me the PowerPoint slides. And then I told them, well, I did it with LaTeX Beamer, I don't have any PowerPoint slides. And that was a very embarrassing discussion. And then they told me that from that point on I have to create everything with PowerPoint. So why I'm using Windows is this compatibility to the project partners and also clients, because they use the reports that I give them in Windows. Then they want to have a Word document, they want to have a PowerPoint presentation. And what I learned over the years is that you can do an excellent job with the simulations, but if you incorrectly present your results, which also means that you give your clients the results in an inconvenient format, for example LaTeX Beamer, where they only have a PDF, and then they cannot just take the slides into their internal slides, or cannot just copy paste text segments from Word into their own reports. That really lowers the value of your work, and I had to learn this the hard way. So this is why I switched to Windows, because here I have all the compatibility, and with the Windows subsystem for Linux, with this I have all the powers of Ubuntu that I need. So here I have combined Linux and Windows 10. So this is why I am currently using that, but maybe next year this is going to change and there is another setup that is even better for me. So this is why I currently use Windows 10. Up to what extent can I raise the Kuro number in RAS? I have a compressible flow with a large grad P and carrying Lagrangian phase. Okay, well, that's the different thing. I cannot afford CO1. FV schemes are upwind. Recommendable. Is it recommendable to use second order? Yes, so it is always recommendable to use second order, but it is better to have first order results than have no results with second order. So if you cannot achieve it, then you have to go with first order. Of course, you should switch to second order if you can. And yeah, Kuro number of 1. For LTS problems or long time stepping problems, you can use a Kuro number of 5 or maybe even 10. But those are almost steady state problems, so they don't change a lot. But if you have a compressible flow with a large pressure gradient, then you will need Kuro number of less than 1, 0.5, 0.2, 0.1, I don't know. So for those problems, you will most probably need a lower Kuro number just to have a stable simulation, and possibly it's a mesh quality thing, so I would double check your mesh quality as well. Okay, so Peter, you jump more between project than expected. How has been your journey with it and which doors has opened? I am really curious as to how No. Why are you simulating a fan and next day blood, for example? Would it be interesting idea to make a journey of this, to make a video of this journey as to guide the future of the current OpenFOAM generations? Now, okay, so why do I do the one day a fan and the other day a blood flow? Well, I cannot really choose between projects. I take what I get. I mean, now with COVID, it's difficult to get projects, so I really have to take whatever I get. And this has, but I did that now for years. Also, when I did my PhD topic, but on the side I also had to work on industrial projects which had nothing to do with my PhD, which was on compressible multiphase flows. I did combustion simulations, reaction simulations. I even did structural mechanics simulations. I did conjugate heat transfer. I did all kinds of topics. So it is natural now to me to just jump around in topics, and because you might know that I now have my own company where I do consulting and similar stuff. So I just have to take whatever I get, and I try to post small snippets just to have a conversation with you guys. Of course, not with the confidential stuff, but with the free stuff. I'm happy to share small snippets of my work with you. So this is why I jump around, just given by the projects that I get. What do you think is the most efficient cloud service for OpenFOAM? I've tried AVS, but it is very hard to find an available instance. About a week or two I came across Fusic. Okay, I don't know that. I will give a try, but I don't know if you have more. So cloud services, yes. So there is Amazon, then of course there is Google. But I've never tried Google. I wanted to try Google Cloud Platform, but I never had the need from the simulation point of view. But I've heard from project partners is that you get, or you can get certain number of cores and then you can just use it. So I haven't heard that there are no instances on Google, and then there is Microsoft, of course, but usually there you only get a bare bone server. I know that on AVS you can have an instance where you have OpenFOAM version 7 or something like that installed, but usually what you get is a bare bone Ubuntu, and then you have to copy OpenFOAM on that and your problems, and then you can start them manually. So this is one thing that I know of. And recently I had contact with the guys at Kaleidosim, so not a sponsor. I want to mention that here. So here these guys also have cloud software, but it is specialized on OpenFOAM. So if I maybe just really quickly log in. Here, there you can create projects, and what I liked here is that you can add projects. You have different versions of OpenFOAM available here, and it is really OpenFOAM oriented. So if you create a case, you can just name it a case, then select a solver, so row, PimpleFOAM or whatever you want. Select the number of cores, then your decomposition, and then what you do is upload your case as a zip file, and then you click start. Start the simulation, so it is very OpenFOAM specific. So this is what I liked it. I tested it a bit, so this is possibly what is also interesting, could be interesting for you. I talked to them, and what I told them what I would need as a developer is another optional possibility to upload user libraries and user applications, which then copied into a temporary user app bin and user lib bin, and then I can run my custom codes, and then after the simulation those libraries and applications are deleted, and then I can get my own problems from that, because here you can only go for the default solvers. So I liked this because this is very OpenFOAM specific, so possibly it would be something for you, possibly not. As I mentioned, you can also try Google Cloud Platform or Microsoft as well. Okay, so next question here. What is the most complex, interesting simulation you performed? Okay, so complex and interesting are two completely different things. Most complex was, I think, during my PhD, the simulation of a kiln, a brick burning kiln, where we modeled the kiln with a CHT model, the kiln itself, the bricks themselves, as well as the fire inside of the kiln. That was, I spent 2 months on the mesh. That was quite something. And then that was the most complex, and the most interesting is possibly what I'm currently working on with fluid structure interaction, which is cerebral, so brain aneurysms. That is a really fun thing to do. And I do present some results at conferences and workshops about that. This is really interesting. Okay, so Stanley, awesome. Let me try first question for programming. Okay, so now we are at programming in OpenFOAM. How did you start learning and understand how to change the OpenFOAM code itself? What would you recommend towards learning how to understand and program in OpenFOAM more efficiently? And I remember that there was a very good answer here from Lookit. I had a discussion with Philip Cardiff. Philip Cardiff is a very, very good programmer from Dublin. And he is one of the authors of Solids for Foam, the FSI library for OpenFOAM. So simple answer: open the code, take a pen and paper, and understand in depth what each line does. Never had the bravery to go for it myself. Yeah, so this is the hard way. So this is also how I learned. I just tried to program during my PhD, tried to program my multi-phase compressible solver. It was a mess, and I'm not very proud of it nowadays. Today I would do it in a completely different way, but oh well. So yeah, learning by doing is the hard way, but it is very efficient. I mean, nowadays we are not in the Stone Age regarding OpenFOAM. So we do have some tutorials. As you may know, I am on the committee for tutorials and documentation. So there are some tutorials here on wiki.openfoam.com/tutorials regarding programming. So there are several tutorials, especially the basics by Håkan Nilsson, and also Joel's tutorials are very, very good. So nowadays I would advise you to go through these tutorials before you do your own stuff. But after you did these tutorials, then yes, so go ahead and just start your own code. Start with scalar transport foam and modify it, or just start with pimple foam and then add a scalar. I guess this is also it. So add a passive scalar to a solver. So step by step, and then you can go for, I don't know, viscosity model or something similar. So this is how I would advise you nowadays, and in 2021. We are not in 2009 anymore. I'm sorry, my question is not the one that needs to be answered on stream, but just a general one. Are you considering making tutorials on overset mesh and dynamic mesh? I will still answer your question here on the stream, although you don't want it. So overset meshes are awesome, and I wanted to do that, but I didn't really have the time to go into depth because I just didn't have the projects, and next to the projects I didn't have the time to just play around with it. So that was something that I wanted to take a look at. Dynamic meshing, sure, also. So this year, in the second half of the year, most probably I will have a project where I will need overset meshes. There I will have the possibility to go in more depth about that. So maybe in the future I will also have the possibility to do tutorials on overset meshes, because they could be game changers, but I just didn't have the time. So Alejandra, hello, thank you very much for this space. I intend to perform FSI simulations, great, in my master thesis, okay? ambitious but great. It involves interaction between human tissue and air particles. Sounds interesting. What are your thoughts on the FSI libraries available in OpenFOAM? Or maybe you think I should try commercial software for this problem. So as I mentioned, I do use FSI, the one that was set up by Željko Tukovic and Philip Cardiff and some other authors as well. So it's called Solids for Foam, and so I use it, and I also contributed to it in a certain small amount. And I'm working with Philip in this project with cerebral aneurysms on that, and also on a separate industrial project. So I think it works great. For elastic problems, I would say just go for it. For elastic problems, it works really nice. For linear elastic, for hyperelastic, that's something we are currently working on. There are models, but I would advise you to at least verify them with Abaqus, if not validate. And if it's a plastic deformation, then I would also advise you to verify or validate it. But for linear elastic models, just go for it. I think it works great. There is no need to go for commercial software. So yeah, sure, go for Solids for Foam. How can we find which boundary conditions are more effective for a particular problem? Which problem is the question? Yeah, so but here you really should go into the OpenFOAM source code. So where can you find the boundary conditions? OpenFOAM 12 SRC finite volume fields FV patch fields. Then here you have all the derived boundary conditions, and usually you do have a rather good turbulent intensity. In the .h file you have a rather good description of the boundary conditions. So what they do, so you just open up the H file and then take a look at them. So these are not all the boundary conditions that you have. You have here some others. So these are derived ones. There are constraints and basic ones like fixed values, and then there are some so in atmospheric models as well as turbulence models, in atmospheric models you have your atmospheric boundary conditions, and then in turbulence models you have also boundary conditions that you can check out. I would always go for the H file and then inspect them. So without knowing what the problem is, I would advise you to go through the available boundary conditions and take a look at the description in the .h files. Okay, how do you perform mesh convergence testing in transient simulation? Does the grid convergence index apply? Sure, so the Richardson extrapolation applies. So what I would not do, because I saw it several times, that people just change the mesh resolution by 20%. So they have a coarse mesh and then they increase the mesh resolution by 20% and 40%. I don't think that's enough for a grid dependent study. I would at least go for double the size or double the refinement and again double the refinement, and have at least 3 grids. Of course, have more if you can afford it from a computational point of view, but so this is how I would do it. And then what I would evaluate is the key parameters. So I don't know, for the outlet temperature or the force on a certain wall or whatever is your key parameter, then plot these as a function of your grid resolution, and then yes, go for the Richardson extrapolation. Alberto, can you explain adaptive mesh refinement or make a tutorial? Adaptive mesh refinement, well, it would take a bit long here. I do have on my channel the multi-phase simulation project
Is the clunky
where
interface?
I do have where I do run a simulation, if I'm not mistaken, for the adaptive mesh refinement. So maybe you can take a look at that video, but it would take a lot of time to describe this. So sorry about that. Maybe I can cover that in an upcoming video. Okay. So, hi Josef, I have a question about reacting foam. Can we add an auto ignition on our solve? I have a geometry which has two inlets for methane and air, and I want to send the gases at 300 Kelvin, but when I send the gases at 300, I can't see any ignition. I need to make inlet air at least 1100 Kelvin. Okay, so this is a very niche problem with reacting foam, but sure, we can talk about that. So, if you use the infinitely fast reaction model, then it will always ignite, because that is a very simple model which then checks how much mass is in a cell, and then it reacts immediately. It is only limited by the mass fraction of oxygen and the fuel. So if you don't have oxygen or fuel, then it will not combust. But if you do have both of them, then it will burn immediately in the cell. And with that model, the infinitely fast model, you will always ignite. With all the others, you won't, as you most probably is in your case. There you can use set fields and then select certain cells where you patch at the beginning a very high temperature of 1100 or 1500 Kelvin, and that will start the combustion. The temperature will dissipate away within a couple of time steps, but then you started your reactions and it will keep your flame alive. So this is how I would advise you to ignite with set fields. What solver and boundary conditions would you use to simulate the mixing of two air streams? One 0.5 at minus 20 degrees Celsius and one at 20 degrees Celsius, assuming subsonic velocities. So this is a temperature dependent problem, so it is and it's a compressible problem, but not highly compressible. So applications and solvers, then I guess what compressible solvers and heat transfer solvers do we have here? So I think that raw pimple foam is a bit of an overkill for you, so I would either go for the buoyant Boussinesq foam or just the buoyant pimple foam. These are slightly compressible models where you concentrate more on thermal effects and not the compressible effects. So I think, so if I'm not sure whether is it a transient, so it doesn't say. So either if it's a transient, then the pimple versions, or if it's a steady state, then a simple version. So I would start with either one of those. Okay, what do you think about the future of open source meshing? Will we ever see SnappyHax Mesh able to generate high quality boundary layers for any geometries? Some kind of powerful block mesh GUI, ratio set up easily, ISAM Hexa, a new OpenFOAM mesher, or there is no choice but go for commercial meshers to ease the pain. Okay, so the boundary layers are the problems. Yes, I know that. So regarding the block mesh GUI, I mean, there is SwiftBlock for Blender, and for some people it works fine. I tried it. I can run it for the tutorial case, but I had issues with my own real-life geometry, so I could never utilize it. So possibly you can use SwiftBlock in the Blender plugin to create a block mesh for complex geometries. But yeah, SnappyHax Mesh and CF Mesh are the only open source versions. So what is my opinion on open source meshing? It's great. So I talked to companies who use StarCCM Plus and OpenFOAM, and they say that the polyhedral automatic mesher is much slower of StarCCM Plus compared to OpenFOAM, to Snappyhex Mesh. So I think it's powerful for 70-80% of the cases, but for certain problems like where your boundary layers are important, yeah, layer creation is problematic. So what can you do? So one thing that you can do, and maybe excuse me here, the paint just for a schematic sketch. So if you have, let's just say, this curved wall here, which is of course not a curved wall, but let's just say this is a curved wall, and then you have your cells here that you put in with Snappy. And then what do you do here during mesh creation? And of course you have then the other cells here. Yeah, meshing in paint. It's great. Okay, so your Snappyhex mesh, and then what you get during layer addition is that here additional layers are being put in, and then you have your layers here. Okay, so for example 3 layers, and they are pushed in from the side. And what you can do instead of using the actual wall here, so let me just, so if this is your STL wall that defines your the wall, you could just reduce the wall by the thickness of your layers. So create your STL files like this, so smaller, so leave away the geometry where you want to put inside the layers, and then select the boundary, so the wall. So I just do it. I just now delete the mesh here. So if we create the mesh with Snappy here without the volume for the layers, so we have our STL file here. And it is not correct, so we still need the volume of the layers. Then what you can do, you can extrude the mesh, and what this will do, it will extrude. You can select in the normal direction extrusion, and then you can extrude 3 layers, and then you will possibly have a better layer addition. Sometimes it doesn't work, especially in 90-degree regions where you then want to extrude your mesh in this direction and in this direction, and then they overlap in the corner. So there this doesn't work. For certain geometries, this extrusion here does work. So possibly this is an alternative, but it is a manual alternative, so you have to set up extrude mesh dictionary. So if I just Google it, extrude mesh dict, there you go. What do you have here? So yeah, so for example, if you Google extrude mesh dict, you can extrude in a linear normal way. That you specify the thickness, how many layer cells you want, and then you can either extrude from a patch, from the mesh, or from an STL file. You don't need the STL file, you have to use the mesh because you want to add the layers plus the original case. So this is a possibility how you could do that. So did I answer all your questions? So Snappyhex Mesh is great, but it has its drawbacks, and the problem with open source meshing is the same like with documentation. Everybody wants a good documentation, just like a good open source mesher, but nobody is really willing to pay for it. So this is the problem. So it is usually initiatives from certain people, or there are financings, some certain finances that come to open source meshing. Then there are some developments, but it's not something that is consistent. So it is great, but it's usually a patchwork, just like the documentation. Okay, so that was it. So maybe I just answer a couple of questions here. So I have my phone here. Let me start at the top. Wow, you have a lot of... Okay, so you can post the questions here. How can you model river bathymetry and some structure with For River and I use STL for River and Snappy, but I have problem to incorporate the structure. Yeah, so for that I would advise you to use Snappy Hexmesh and to take a look at the multi-phase simulation project. Your problem is going to be difficult, so you will most probably need a bigger computer, but yeah, so Interfoam and Snappy Hexmesh. I compare the performance of OpenFOAM on Windows about 2 times slower. Yeah, so I guess the question is from Georgi is that the comparison between native Ubuntu and Windows. So what I do, I set up my cases on Windows, and then I have right next to me 2 Ubuntu server workstations, and there I copy my cases and run my simulations on a server edition of Ubuntu. So I still use for simulations Ubuntu server, but for case setup, pre-processing and post-processing, I use VSL. So I don't run my simulations on my laptop. Which turbulence model could be used for problems with characteristic length smaller than the boundary layer? Small gaps. DES or LAS, but I'm not an expert on that. Small cases I had less than 20% slowdowns on VSL. Yeah, so I also tested it and I also had just a couple of percent. So maybe it's on big cases the difference is bigger. So I would advise you to use Ubuntu server for bigger cases and only run small cases and case setups on your Windows machine, if you can afford a second PC. Okay, so discussion on VSS, or if you give a lecture on or a video on compilation of other solvers facing with ZFoam. Yeah, so I don't know, this is a very specific problem with ZFoam. Have you tried Docker, compared Docker or Linux? Is there any other fluid structure interaction solver? Not to my knowledge, so Solid4Foam is the only one. Darius, thank you for your videos. I was wondering if it is possible to use non-conformous mesh for CHD. Yes, it is possible. You have to change the mapped wall type in the constant polymesh boundary. So you can use AMI interpolation for CHD, but I think you can do it. You can only change it manually. So what I would do, I would just set up your case, and then whenever you set up your mapped walls in the mesh, then just go into constant polymesh boundary and then change the type. Not the mapped field types, but I'm not sure what it is called, but there is a second type of interpolation, and there just type in blah 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 and then start your simulation, and you will get an error message, what models are available, and then go for the AMI interpolation. Okay, Franco, for my question about troubleshooting Snappy, thanks for the answer. When I have that result, I have skewness and concave cells. What I should change in Snappy, or should I ignore? Okay, so do I have it still here? So concaveness, this is what I mentioned, that CheckMesh is too strict. So I wouldn't worry about concaveness, just check it out, and if your gut feeling says that's perfectly fine, then just ignore. I usually ignore skewness and concaveness unless I really see in those in those files, if I open them up in ParaView, that something is fishy, then I just ignore them. So yes. Compared to Ubuntu on Foam Extend. Okay, hi Josef, thank you for all the help, you're welcome. It is stated that using OpenFOAM via Docker do not degrade the performance. I really wonder if this is true or not. I don't think it is possible though. I don't use Docker. Hello Josef, congratulations for your work, it is helping a lot, thank you. Performance comparison OpenFOAM. So Georgi is talking about his experience, so thank you Georgi for your inputs. Come on, please change some of the settings of your terminal, disable beeps at least. Okay, sorry. Did my link appear? Use uBlock origin. Hi, thank you very much for your excellent tutorials. I'm going to do simulations of cavitation inside of kernel. Good luck. Which tutorials and solver would you recommend for that? I think there is cavitating foam. There isn't there? Cavitating dime foam, cavitating foam. These are the two solvers that you can use. No, not. So this is what I would advise you. And I'm unable to find baseline Reynolds stress models in OpenFOAM. Is there any recommendation? So if it's not there, then it's not implemented, then you have to implement it yourself or go for another Reynolds stress model. Check please SimCon article. So yeah, please check Gregory's link if you're interested. Problematic in cases with BL is important in all cases then. Okay. I see that paint is not bad for meshing. For these purposes it is good enough. How can you model river? Okay, I think I already talked about river modeling. Just Interfoam and Snappy Hex Mesh and try it. Star CCM polyhedral meshes slower than Snappy. I love OpenFOAM. Yes, this is what I heard. So I didn't run it myself. I just heard that. But the difference is quiet for the meshing, and the polyhedral meshing in Star is incredibly faster. So what you can do, you can use Salome and then run the TET mesher there, and then there you can export the mesh as in UNV format, import it to OpenFOAM, and then execute poly dual mesh. This should convert tetrahedral meshes to polyhedra. So I've never tried it, but people told me that they do it in cases where they can only get away with tet meshes. There the tet mesh is converted to polyhedra, and then polyhedra are better for OpenFOAM. So this is what I can say to you regarding polyhedral meshes. Okay, so what books would you recommend for learning fluid dynamics? I posted today a video, or no, I didn't post, but I will post a video on that soon. I recorded that video. I don't have the link. So the OpenFOAM Technology Primer is a book that was released a couple of years ago, and then the authors now updated it to version 2012, and they released it under Creative Commons on the internet, so you can download the PDF. I will post that video next week or in 2 weeks, so watch out for that, and then you can download the PDF for free. And make sure to thank them, because this is nothing self-evident that people just provide their book for free. There are no measures, state-of-the-art commercial, unfortunately. The book for... Okay, so there is a book recommendation. Hi, Josef, did you work with Gmesh? No experience with Gmesh, unfortunately. Why is Foamy Hex Mesh not much used? It was an initiative that was funded for a while and then never continued, so this is the reason. How can we fix the pressure of a cell set through the simulation time? I'm using pimple foam. How can we fix the pressure? I'm not sure about that. Hi, much appreciate your time and videos. I need to model a tight screen with air and don't think explicitly defining the mesh is press. Any tips? So again, I need to model a tight screen with air and don't think explicitly defining the mesh is practical. Any tips, please? I'm not sure, so I'd have to see the problem here. Sorry. Can you visualize every other point when visualizing fine meshes in ParkView? Every other point when visualizing fine meshes. So yes. Reduce the resolution. I am not aware of that, but maybe someone knows, because I do get some very useful comments on that. So please, if you know how to reduce the point size in ParaView for large meshes, just please comment. Polydual mesh will fail if you add prism layers. Yes, I know. So polydual works only for tetrahedral. This is true. Oh, good bit of luck there with the books. Thanks. Can you make an example of dynamic mesh with removing cells as you move? Could be something for the future, but I cannot promise anything. Can you please also recommend your settings for always get complete full layers? The magic settings, so I don't think that's possible to have a magic setting, so I'm not sure. Do you know this PDF? Comprehensive tour of Snappy Hex Mesh. So are you familiar with this PDF? This is a PDF from 2012, so it is a bit older, by one of the programmers of Snappy Hex Mesh, and there you have a very detailed explanation and also layer control, so possibly this helps, but there is no one setting that you can use, so sorry about that. Full layers. Air is passing through like a filter. Possibly porous media. If I understand correctly. You are so cracks. Can you please give me hints on how FV options work in OpenFOAM? How do FV options work? Okay, I can possibly try and go through some of the settings. Maybe that's interesting for everyone else. So let's just go back to that Patreon problem, tutorials, 3D elbow, and then I will just finish because it's already 4. Okay, so FV solution is what you are looking for. So I'm not sure what you are exactly looking for. So here you have the solvers. So for the quantities where you solve the differential equations, and then you can choose the matrix solvers. There are different matrix solvers: PCG, GAMG, smooth solver, preconditioner, and then what is a numerical setting is the tolerance. So until which residual do you want to solve the equations, and when do you want to stop? Then you have simple or pimple settings. So do you want how many non-orthogonal correctors? For transient simulations, here you can set different numbers of loops in a time step: inner correctors, the non-orthogonal correctors, then n correctors, and also n outer correctors. Then for steady state, here you can specify the residual at which the simulation is considered to be convergent. And then for steady state, you also have here under relaxation factors. So I'm not sure whether this helps, but this is the basic setup of FV solution. So mesh generator from binary image. I'm not sure what you mean, but because I don't know what you mean, I don't think I can advise you with a mesh generator. Okay, so if there are no additional comments, then it's time, guys. So thank you. So make sure to like this video and this live stream, and also subscribe to the channel, and please also hit the bell if you haven't done so already on my channel. It's usually here somewhere, and if you like this, then we can do this a regular thing every 2 weeks or once a month. Just make suggestions in the comment in the video. So the live stream is going to be available later on my channel, so just comment there or in the community tab below either this post or the live stream post. What do you think about these Q&A sessions? Maybe another topic for a live stream. I cannot promise to live program you something here, a specific problem, but a Q&A or is something that's fun and can be done in an hour or something like that. I'm happy to do so in live streams, and then maybe we can do this a regular thing. So thank you, everyone. I will just now close the stream here, and I I would like to thank you for watching and listening, and I hope to see you